This brings me to the last first principle. How many of you have heard of the laws of thermodynamics? There are 4 laws of thermodynamics. 2 affect us directly, and the other 2 are reference points scientists need to keep track of how the other 2 work. Jeremy Rifkin developed a thermodynamic perspective of economics and the environment in his book, Entropy. The first law of thermodynamics states that matter and energy can never be created or destroyed, they can only change form. Since the universe is finite, that means the energy content of the universe is finite. To explain why the universe is finite would require me to explain some astrophysics, which is more of a distraction than it's worth. But you can find it in A Brief History of Time by Stephen Hawking. The short version for why the universe is finite as far as it concerns us is that we are moving away from the center of the universe, and the edge of the universe is moving away from us at the speed of light. So, even if there is energy being created in the center of the universe, or there is energy outside the universe in whatever the universe is expanding into, neither of those points will ever be accessible to us. The visible universe is roughly 30 billion light-years in diameter. It is not infinitely large, nor is it infinitely hot. Therefore, it can't contain an infinite supply of energy. The second law of thermodynamics states that energy and matter always move from areas of high concentration to areas of low concentration more than they move from areas of low concentration to areas of high concentration. This is entropy. This is why the soles of your shoes wear out. Heat always moves toward cold. Batteries run down eventually. People get old and die. Everything wears out eventually. For that matter, as Gollum said in The Hobbit, "This thing all things devours, birds, beasts, trees, flowers, gnaws iron, bites steel, grinds hard stones to meal, slays king, ruins town, and beats high mountain down." Contrary to the way Bilbo Baggins answered that riddle, the answer is not time. It's the second law of thermodynamics. Any time anything on the Earth moves, it takes energy to move, and friction turns some of that energy into heat. The heat radiates off the Earth and out into space. We keep getting more energy from the sun, but if we make energy leave the global environment faster than it's being added to the global environment, our energy supply is going to run down. The laws of thermodynamics are another big blind spot in our natural perception of the world. These 2 laws of thermodynamics create the economic system of the universe because they determine the flow of matter and energy through the universe. Evolution is an eddy that flows against the current of the economic system of the universe. But we can't naturally perceive that. We naturally perceive that high concentrations of matter and energy are good because those are necessary to support life. But the economic system of the universe makes matter and energy move in the opposite direction from the way we naturally feel they're supposed to move. The economy of the Earth's environment is powered by sunlight. Plants absorb sunlight through their leaves. That powers chemical reactions between carbon dioxide and water molecules. That creates the hydrocarbon molecules that make the plant grow, and the energy is stored in the chemical bonds of the molecules. If you cut down a tree and burn it for firewood, the heat and light of your fire is sunlight that you're releasing from the wood by breaking the hydrocarbon molecules. When you eat fruit or vegetables, you're absorbing sunlight to power your own body. And when you eat meat, you're eating sunlight that the animal ate. And so it goes for the entire food cycle of the world. So now we have two more problems here. The first is that as the Europeans went on using their Stone Age brains and their increasing technological levels to make the best decisions they could think of to maximize their genetic survival, exponential population growth and the laws of thermodynamics caught up with them. When they cut down all their forests, they ran out of energy to power their wood-based economy. So they started looking for other things they could burn, and they discovered coal. Coal is wood that's been crushed under mountains. That means the hydrocarbon molecules are packed together much more tightly. That means you can build bigger, hotter fires with coal. The Europeans' discovery of coal, combined with their scientific and technological level, made the Industrial Revolution possible. Coal, oil, natural gas, and nuclear power are all non-renewable forms of energy. We're burning them faster than they're being replaced. When each of those things was first discovered, there seemed to be way more of them than anyone could possibly use. And that means the same thing as infinite. There can't possibly be an infinite amount of oil in the ground because the Earth would have to be infinitely large. But instead of thinking of all that, people just went right on using their Stone Age brains and their current knowledge level to make the best plans for the future they could think of to maximize their genetic survival. And our economy has been running down a dead end ever since. There's a lot of talk now about using renewable energy. Wind power is the cleanest form of energy of all. But even if we suppose the most optimistic scenario of all, and we could build enough wind power stations to power the entire global economy, there's still one physically insurmountable problem: the second law of thermodynamics. The wind turbines, or at least the electrical power lines, would have to be made out of metal. Metal is a non-renewable resource. The metal parts will wear out over time. They will slowly turn into microscopic dust that will blow away on the wind and be impossible to recycle, and there isn't an infinite supply of metal to build replacement parts with. A biological economy powered directly by sunlight is the only kind that is sustainable indefinitely. Energy in equals energy out. An economy founded on patterns that keep perpetuating themselves is the only kind that can keep from being completely run down by entropy. Everything in the world that isn't alive wears out eventually. Everything in the world that is alive keeps replicating its genes, because life is a self-perpetuating pattern that's powered by the sun. A biological economy powered entirely by sunlight means a localized organic agricultural economy. But that can't save us right now because a worldwide localized organic agricultural economy couldn't produce enough food to feed everyone who's alive right now. People are able to live packed together in cities because we're using industrial machinery to transport food and refrigerate it. However, we can use our industrial machinery now to convert to a renewable energy infrastructure that can power our industrial economy for a few more centuries. That would give us time to cut down our population size by everyone having small families, and otherwise adapt to localized organic agriculture. Lester Brown shows how our economy could be converted to mainly running on wind power in his book Plan B 3.0.